This call is now being recorded.
Okay, so good afternoon to everyone. Today we are going to discuss about the concept called nonlinear optical fiber. So in this session, we are going to discuss about the nonlinear behavior of optical fiber. But the previous class, we discussed about that amplifier. So the amplifier is we discussed three type of amplifier. So one is doped amplifier and parametric amplifier, Raman amplifier. There are three types of amplifiers we discuss, and electronic based optical amplifier also we discuss. So this is the thing what we discussed in the last class. This class, the non-linear effects of optical fiber. So what is the non-linear effects in optical fiber is stimulated scattering. So the stimulated scattering will be divided by two types. One is Brillouin scattering and Raman scattering. And another one is optical Kerr effect, which is same phase modulation, cross phase modulation, and four wave mixing. This is the non-linear effects. The general effects of stimulated scattering and optical Kerr effects are the major classification of our nonlinear effects. In this stimulated scattering, two types, and optical Kerr effects, there is a three types. So this is the content what we are going to discuss today. So due to the nonlinear effects, the light waves and the materials are transmitting. Nonlinear effects are weak at low powers, much stronger at high power. Suppose the waves or the nonlinear effects the effects is very weak. At low power, the effect is very low. At high power, the effect is very high. That can result when power is increased or when it is concentrated in a small, such as core or single mode optical fiber, and it's accumulated to pass through many kilometers of single mode fiber. What is again is the nonlinear effects continuations. The refractive index F we consider, suppose if the refractive index, which is F, that is a frequency or light intensity, the optical power can be increased to overcome losses. So due to the nonlinear effects, the significant at high optical and power densities in a long single mode fiber. So the optical system performance degrades the reductions in power gain, in power at different wavelengths, frequency shift, adjacent channel, and crosstalk wavelength conversions. The nonlinear, already we discussed, the nonlinear effect is simulated scattering and optical Kerr effect. This can be useful for amplification. So this is the Kerr effect. The Kerr effect is what? Can you see the slide? Can you see the slide now?
Yes.
Yeah. So what is the Kerr effect is self-phase modulation and cross-phase modulation and four-wave mixing. Scattering effects is stimulated Raman scattering and stimulated Brillouin scattering. Stimulated Brillouin scattering means, what is the scattering? Scattering means when the light is incident in a particular plane, then in all the directions or reflections happen is called scattering. So the modulation of light through the thermal or molecular vibration within fiber. The scattered light appears as upper lower sideband whenever it is incident in a photon after scattering produces phenon and of acoustic frequency as well as the scattered photon. The third point is important. Can you see? Wait a minute. I will take the pen actually. This mode is not good for me. I will take this mode. Yeah. Now, I can take the pen actually. Please. So I'll take. So this is the. Can you see? Okay. I think My slide is visible or not? No?
No for
No, no, no.
No. Okay. Right. Okay. The slideshow view is not up. I'm not showing. Only the reading view is possible. Okay. Couldn't highlight. That's the problem. Can you see my yeah? Can you see my cursor? Yeah, you can see my cursor. Yeah, that's okay. So, is there any annotations possible? Just some moment. Oh my goodness. Okay, the cursor only the possible. Okay, it's okay. I think you can see my cursor. Please just get with my cursor. Yeah. So in this case, the third point is very important. The third point, incident photon after scattering produces as a phenomena of acoustic frequency as well as scattered photons. All of you get the point. So when my incident photon, when the light is fell on a plane, it produces some scattering. What is scattering? What it produces? First of all, the phonon of acoustic frequency. So first acoustic sound frequencies is coming to a sound frequency as well as the photon. So the photon of acoustic frequency and its scattered photon. These two things together is called Brillouin scattering. So Brillouin scattering is that when the light is falling down, then it is what happened. It is divided into two parts. It is divided into the two parts. Then we can say that parts all are to be a all are to be the concept called it's divided into two types. It's divided into two types. Mm, I need a pen actually. Just give me a time. I will take a pen and I want to draw the things on top. Or you can open the board. The whiteboard. I will take a whiteboard. Because I need a pen to explain. That's why I'm looking on it. Just give me a second. I'll take my pen and board. That is a pen. Okay. 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 No issue. No issue. And I'll continue as it is. I said no. Okay. If it is a slide view, I can make annotations, but no issue. So I think we can slideshow view. Why it is rejecting? I don't know. Yeah, it's rejecting the slideshow. Okay. Okay, finally, I can make a drawing. After finishing, I will make a drawing and I will explain those things. Okay. So now you can see follow as a PPT. So actually, I have a plan for write up and giving diagrammatic explanations. It's okay. So what happened? The third point was that my scattering is divided into two parts. One is acoustic frequency, another one is scattered photon. This is called Brillouin scattering. And the frequency of the sound wave varies with the acoustics of length. Because my photon get divided into two types. One is frequency of sound, another one is frequency of light. This two scattering is known as stimulated Brillouin scattering. This comes under the nonlinear effect of our optical case. It produces optical frequency with various scattering angle. The phonon means the quantum of elastic wave in a crystal lattice. When the elastic wave has a frequency f, the quantized unit of phonon has energy of E is equal to hf joules. That we know that E is equal to hf joules. H is a Planck's constant. So energy is directly proportional to the frequency of the elastic wave. So if the frequency of elastic wave is increased, automatically the energy also increases. The stimulated scattering, it's showing the threshold power. What is the threshold power? PB is equal to 4.4 10 to the power of minus 3 d squared lambda squared alpha dB. So the d is the fiber core diameter. The lambda is the operating frequency. V is the wavelength, and these are all the things what we. So d lambda alpha is what? Alpha is a fiber attenuation. You got the point? The threshold power of Brillouin scattering is 4.4 into 10 to the power of 3 d squared lambda squared alpha dB V. This is the stimulated Brillouin scattering. And the threshold power P Brillouin is there. It's 40 to one more. This previous is the general threshold power. This is the threshold power of Brillouin. So it's giving the acoustic interaction. What is the shift will be given. So VP is what is VP? We have two the bandwidth. The VP is a signal line bandwidth. VB is the Brillouin gain bandwidth. This is VB was Brillouin gain bandwidth, and VP is the signal bandwidth. So okay, A effective is the effective core area. A is the effective core area. So and GB is the Brillouin gain coefficient. GB is a Brillouin gain coefficient. This is the stimulated Brillouin scattering formula. How to calculate the Brillouin threshold power. So the nonlinear effects contributes the signal impairment, additional power needed to receiver to maintain the same BER. So due to the nonlinear effect, we need the total system is consume more power. That's a problem because my data get divided into two parts. One is sound as well as the photon. So the sound and photons divided means automatically my energy will be reduced. So to enhance the energy, I need to give a more power in the receiver side. That's a problem. So reduction in power penalty. The power level per WDM. What is WDM? Anyone can? What is WDM? WDM means what? Wavelength division multiplexing. What is WDM? This is the wavelength division multiplexing. So in the wavelength division multiplexing, the channel kept much below SBS threshold, spacing between the amplifier stages, reducing long haul system. Therefore, my power the level of my power is keep on varying by using the nonlinear effect. Therefore, the line width increased by direct modulation of source may result dispersion, but can be reduced by dispersion management. So, if the line width increasing means the dispersion of the light wave also is increasing, but it can be manageable. The next one is stimulated Raman scattering. The previous one is what? Stimulated. What is this? Anyone can say what is this? Stimulated? Yes, please. Please speak. This is what stimulated. Yes. Are you there and available? All of you available? Salam, Sirna. Salam, Sirna, only Alan. Yeah. What is stimulated? What is this? Stimulated?
Brillouin scattering.
Brilliant scattering. Very good. Stimulated Brillouin scattering. Now we are moving to stimulated
Raman.
Yeah, stimulated. Very good. Thank you, Salam, Miss Salam. So stimulated Raman scattering. So what is Raman scattering is here you can see the interaction between incident optical signal that's called photon and the molecular vibrations. Molecular vibrations. Here, the scattering of photon, a high frequency optical phonon generated. The frequency of energy of incident photon reduces the modified photon is called Stokes photon. Here, my frequency is not converted into sound energy. My frequency, my light energy is converted into light only. But what is the light? Some part of the energy of the incident photon absorbed by the molecules. You know, for example, if some of the energy will be absorbed by the molecule, then what will be the result? Less energy will be released. So automatically the photon energy will be reduces. That's known as Stokes photon. What is that? That's called Stokes photon. Stokes photon. So there is an incident optical signals called pump wave. Reduction of frequency is called what? Stokes frequency. There is a Stokes frequency. There are two types of frequencies. The incident wave is pump. Released. What is the wave which is released from the molecular is called Stokes frequency. There are two types of frequencies are generated by the scattering. This type of scattering is known as Raman scattering. So Raman threshold, the input power level that can be induced by scattering the half of the power. Half of the power is minus 3 dB. Minus 3 dB is the half of the power. This is the stimulated Raman scattering. Raman scattering threshold is, you can see, PR is equal to 5.9 10 to the power of minus 2 d squared by lambda alpha dB. You know, see here is what? PB is what? 4.5 10 to the power of minus 3 d squared lambda squared alpha dB. This is the Brillouin scattering, but is Raman scattering, you can see 5.9 10 to the power of only that is 4.4, here 5.5. And P Raman is 32 alpha A effective by GR. There is no VP and VN. You can see Brillouin. So Brillouin scattering, you can see 42 alpha A plus 1 plus VP and VB it was there. But here it is two different formulas. P Raman threshold is, this is the power of Raman threshold and this coefficients. So reduction of SRS power penalty is here the reducing channel spacing, channel power level below the threshold level, distance between amplifier to be reduced. The channel dispersion reduces SRS. So the channel, there is some small amount of dispersion means my light will be scattered in a different angle. This is called dispersion. Raman versus Brillouin scattering. What is the difference between Raman and Brillouin is there is a SBS and SRS not usually observed in multi-mode fibers. Brillouin threshold occurs at an optical power level around 80 milliwatts. Raman threshold occurs what? 17 times larger. Raman effect is 80 milliwatts means 80 into 17. 80 into 17, how much can you calculate? 80 into 17. Take a calculator and tell me. Take a calculator. 80 into 70. 17. How much? $80 into 17. How much?
1470.
17
1470.
1470. So very good. So that much milliwatts was there in Raman scattering. So yeah. So this is the difference between the power of Raman scattering is very high compared to the power of Brillouin thresholds. So that is the thing. So Raman versus Brillouin scattering is again Brillouin shift from photon acoustic photon interaction. Raman shift from optical photon interaction. You got it? This is very important point. All of you please make it in your mind. Brillouin will be shift. What is the shift here? Acoustic photon. Sound will be produced. The sound will be produced by Brillouin shift, but the optical dispersion is produced by Raman effect. This is the two important difference between Raman and Brillouin. And SBS backward directions and SR in both forward and backward direction. Brillouin scattering due to the broad types of scattering and large number of molecules are involved. Raman scattering due to the individual molecular motions. So Raman scatterings are completely based on individual molecular motion, but the Brillouin scattering is based on acoustic wave and large molecules involved. This is the shift is SBS shift is 0.9 nanometer, SRS shift is 100 nanometer to 1550 nanometer shift. That is things what we just now, because it is 17 times greater than the Brillouin shift. So Brillouin gain width is extremely narrow than the Raman gain bandwidth. So that is the Raman bandwidth is very high, but the Brillouin bandwidth is very low. These are the problem of Brillouin scattering technique. So electro-optic effects changes in refraction index of a material due to the external electric field. What is the electro-optic effect? What is electro-optic effect means? My signal, my light signal is affected by electrical signal. You know, electric signal also a magnet is there. So under the magnetic field, my electric fields, my optical will be get disturbance. So the electro-optic effect means the refractive index of a material is changes due to the external electric field. My refractive index will keep on changing by electric field. It's called electro-optic effect. This field modulates the optical properties of the device. So first and second order effects are refractive index as a function of applied and electric field. This is the electro-optic effects. So this is the first order. E square means second order. E means first order. So N dash is equal to N of E. So it's the electro-optic effect formula. This is, in this case, what is K? I'll have to listen carefully. Changes due to the second order term is called the Kerr effect. Second order is what? What is second order? A2. Can you see the equation? A2 E square. Yes or no? A2 E square. So the A2 E square can be represents what? In this here you can see my cursor. Actually, can you see my cursor? Yeah. Lambda K E square. You know, A can be represented by lambda K E square. This K is called Kerr coefficient. What is that? This K is called Kerr. This effect is known as Kerr effect. So already, do you remember that? I want to show you the very first slide. So Kerr effect is, this is the Kerr effect, right? Kerr effect is what? Self-phase modulation, cross-phase modulation, and four-wave mixing. Scattering effect is what? Stimulated Raman scattering and stimulated. So now we finished these two. Scattering effects. What is stimulated Raman scattering and stimulated Brillouin scattering? Now we are moving to Kerr effect. The Kerr effects under the electro-optic effects. What is Kerr effect? Electro-optic effect. Electro-optic effects means my the core of the fiber optic will be changed by electromagnetic effect. That's why its index will be keep on changing. So this is the Kerr effect. What is Kerr effect? Anyone can read? Alan is there? Alan, can you read the Kerr effect? Yeah.
It changes the refractive index material of a matter to response electric field.
Yeah, very good. Thank you. Thank you so much. Keep mute. So Kerr effect or the quadratic effect, you can say the Kerr effect or quadratic effect, a quadratic electro-optic effect. The two names both are same. So we can say that is a Kerr effect. So yeah, you can mute Mr. Allen. I think better. So the Kerr effect means the changes in the refractive index of a material in response to what is that? Electric field. So when the electric field is changing, automatically the refractive index of the core is changing. It's called Kerr effect. Electric field is due to the light itself, the proportion of local irradiance of the light. Next one is what? Four-wave mixing. Four-wave mixing, self-phase modulation, and cross-phase. These are all the effect of what? Kerr effect. The Kerr effect produces what? Four-wave mixing, self-phase modulation, and cross-phase mod. What is Kerr effect? Due to the electric field, my refractive index of the optical fiber is keep on changing. That is the effect of. This is a four-wave mixing. You can see what is four-wave mixing means, or four-photon mixing. You can see the diagram here. There are three optical frequency F1. You can see this is what in this diagram. You can see F1 and what F2 and F3 and FTWM. FWM means what? What is FWM? Mr. Salam, can you see what is FWM? FWM means what?
F1 plus F2 minus F3.
Yeah, excellent, excellent. Thank you so much. You're mute yourself. So FWM means it is the combination of these three waves. The combination of three waves. What happened? This FWM means the four-wave mixing. FWM means four-wave mixing means these three waves are mixed and produce a new wave that is called the fourth wave. What is fourth wave? The three waves F1, F2, F3. These three waves are mixing together and they are creating another fourth wave that is called four-wave mixing effect. This is done by when the optical energy is under the electric field. I have four-wave mixing property, the phenomena. This phenomena is known as four-wave mixing. In four-wave mixing, the electric field can be represented by J2 pi W, and the component of electric field is the D susceptibility. This symbol is known as susceptibility E1, E2, E3, e power minus alpha divided by L by 2 F alpha. So the F alpha, L and del beta is a function of fiber loss. All of you please note it down. It is a function of loss, fiber length and propagation variation, mismatch related to the channel state dispersion. So our electric field is a function of loss as well as my electric field in a imaginary part of the functionality. So this is the electric field of four-wave mixing. FWM means four-wave mixing. What is the effect? The effect from Kerr effect. This is effect from the Kerr effect. So the output of the FWM efficiency depends upon refractive index, fiber length, chromatic dispersion, channel spacing, power densities, higher order and polarization properties of the material. So this is the dependency of four-wave mixing. And four-wave mixing, the number of generated signal M is equal to N squared into N minus 1 divided by 2. So this is the number of FW generated by the signalist. This is the formula to how much to be generated. The N signal are involved in the FWM process. The FWM efficiency depends on the material dispersion, channel separation, fiber length, and optical power length, and each contribution. Reducing FWM, we cannot entirely eliminate the FWM, that is a four-wave mixing, but we can reduce. How can we reduce this FWM? Is uneven spacing. We can make uneven spacing, increasing the channel spacing, power to be launched in the optical fiber is reduced, near to zero net chromatic dispersion. By using this four technique, we can reduce the FWM, that is a four-wave mixing effect in our optical fiber cable. Next one is self-phase modulation. What is self-phase modulation is the phase shift changes the distance between the peaks of an oscillating function and oscillation frequency along the horizontal axis. So the optical pulse exhibit a phase shift induced by refractive index. Refractive index varies with intensity of optical signal. This is called self-phase modulation. So self-phase modulation depends upon what? Refractive index and intensity of optical signal. Please note it down. All of you take a pen and paper. All of you take a pen and paper. Now you can write it down. Self-phase modulation. This 2 point. What is the 2 point? Refractive index and intensity of optical signal. All of you please take a pen and paper and you just note it down that the self-phase modulation is what? Phase shift induced by refractive index and it varies with intensity of if the intensity of optical signal is high, the refractive index also high. So it varies with the intensity of optical. Most intense region of the pulse are slow down and most exhibit greatest phase shift. So most intense signal produce most phase shift. So the intense of the optic signal and intense and the phase shift of the signal is completely directly proportional with each other. The phase shift changes the distance between the peaks of an oscillating function, oscillating frequency also. So you can see here, all of you see here, there is a looking like what? The wave is the first here you can see the wave is very dense. Here wave is what? Very low. The frequency is high. Here the frequency is low. So this phase shift can be done because of the horizontal axis. So this is varied with the frequency. So this is called self-phase modulation. Self-phase modulation. Got my point? Got it, all of you? This is an example of self-phase modulation. Yeah. So here you can see this is the chipped pulse, same envelope. This is unchipped pulse, broaden the pulse in frequency domain, not in the time domain. So this is the time domain. So you can see there is a huge crowded part which is in the starting region and keep on reducing with the line. So this is also a self-phase modulation. This is the how much the self-phase modulation, the pi, the angle will be L. L means the distance and tau. Tau is the time. So L tau, which is the it depends upon 2 pi n naught L divided by lambda plus 2 pi n to L effective by lambda. What is L effective is that it is the effective transmission distance, which is 1 e power minus alpha L by alpha. This is the L effective self-phase modulation. The angle of shifting and the effective transmission distance is given clearly. Next one is cross-phase modulation. Next one is cross-phase. What is cross-phase modulation? Is due to the nonlinear effect. The index on optical intensity effect of a refractive index on optical intensity can result crosstalk among the WDM. Crosstalk means what? It's mixing. It's like a intersymbol interference, or it's like a intersymbol interference on the co-channel or adjacent co-channel or co-channel and adjacent channel. It's like a co-channel interference, like so many light waves are combined. They are mixing with each other. So that's a problem. So that is a cross-phase modulation. So which is given by the formula here. The formula is completely compared to the previous formula. You can see only these two things are available. But here the same formula with what? Ij of tau plus this function is given. This Im is known as optical intensity of the mth channel. What is this? I means what? What is I? I is here represents I means it is the optical intensity of the M means M channel, J means J channel. Clear? Yes. The cross-phase modulation, the wave signals are CPM dominates over the SPM. SPM means self-phase modulation. What is SPM? SPM means what? Self-phase modulation. CPM means cross-phase modulation. This is the cross-phase modulation. Okay. So the continuous waves, the CPM dominates over the SPM. So the CPM is more dominated compared to the SPM. The strongest when pulse completely overlap one another. Low probability of channels simultaneously transmitting bit 1 reduces the effect of CPM on average. The pulse at different wavelength travel at different group velocities past pulse to walk off from another. So this is produced the crosstalk effect. Crosstalk means a different spectrum of the light signal can be interfaced with each other. It's known as crosstalk or cross-phase modulation. You can see here. Can you see? Now what happened? One means, what is one? One means one signal. 0 means no signal. 1 means one signal. 0. So 1, 0, 1, 1. This is my binary data. It is a pulse what we develop. After that, what happened? It will keep on is the wave. So here what happened is looking like what? Anyone can say is looking like what? I don't know. Who is going to answer? It's looking like what? This one, this overlapping of the spectrum is looking like what? Overlapping of the spectrum. Anyone can say?
Crosstalk or collision.
Yeah, very good. Aliasing. It's looking like aliasing effect. It's looking like aliasing effect. Already we discussed in DSP. Very good, Mr. Allen. So it's looking like aliasing. It is a crosstalk. The two spectrums are overlap each other. It's called as intrasymbol interference. So intrasymbols are connecting together, is producing. So this is the cross-phase modulation. Okay, self-phase modulation. This is a cross-phase modulation. So the cross-phase modulation is in WDM. WDM means what? Wave division multiplex. So more than dispersions, it is minimize the impairment caused by CPM, and it is caused by separation or local dispersion by properly chosen. So the more the dispersion discrepancies among the channel, more rapidly pulse walk off from another, one another. Walk off means it's moving to another. Walk off means what? It is moving to another. So this is about the concept of what we discussed today is that nonlinear effects. The nonlinear effects in this nonlinear effects, we discuss what? What are the things we discussed today? This is the point we will discuss. So the one is stimulated scattering. Sorry. So what we discussed today, we discussed today is the first topic, what we discussed today is that you can see. So stimulated scattering, it is divided by 2. Oh, Akime is coming. Oh, welcome. I can see Akime. Welcome. And even Reddit.
Thank you.
Yeah. Today Reddit is coming. Everybody give a very round applause for welcoming Reddit, because it's very rare case actually. It's a rare case. Reddit, what happened? I want to see your face. How are you? Reddit? Okay, maybe. Right. So I'll just conclude that. So nonlinear effects is that stimulated scattering, and it's a different Brillouin scattering and Raman scattering. Anyone can say what is the difference between Brillouin scattering and Raman scattering? Salam, Agmas, or Sirna, or Allen. Anyone can? What is the difference between Brillouin and Raman scattering? Anyone? Even right or wrong, don't worry. Just you can answer it.
Okay, thank you. The Raman scattering is optical and the Brillouin is acoustic.
Excellent. Everyone give an applause. Actually, I'll give applause for her. So great. So what is Brillouin scattering? Brillouin scattering, my photon is divided by 2 parts. One is photon as well as acoustic. Raman scattering, only the acoustic. Raman scattering done by molecular behavior. Brillouin scattering is done by the whole molecule as well as the structure of the molecule. So that is a difference between the Kerr effect. What is Kerr effect? Kerr effect means due to the non-linearity. Anyone can say what is Kerr effect? Kerr effect. Mr. Sirna, is possible? Can you say the Kerr effect? Kerr effect means, I can show you, the Kerr effect is called what is Kerr effect? The Kerr effect, I can show you, yeah. The Kerr effect means electro-optic effects. Electro-optic effect means when the optical system under the electricity, the refractive index is changing. It's called electro-optic effect. What is a four-way mixing? Four-way mixing means what? Anyone? Alan? Four-way mixing means what? What is four-way mixing? Yeah, red it. Yeah, red it, please. Kim?
Sir, I can see the presentation slides on the screen. What shall I do? Sorry.
Okay, okay, okay. You couldn't see the slide? The dates? Okay. So what is four-way mixing is the three waves are added together and the fourth wave is static. What is the thing? The three waves are, the three optical frequency are mixing together. Actually, the Kerr effect Kerr effect is there. The Kerr effect is mixing of optical frequencies. That is called Kerr effect. You got it? So the Kerr effect is, I can show you directly here. You can see here. You can see here the nonlinear effects are two types of effects. One is Kerr effects, another one is scattering effects. The Kerr effects is by self-phase modulation, cross-phase modulation, four-way mixing. Self-phase modulation is the frequency itself, it is get overcrowded and is normal crowded. I mean, it is the frequency shift will be happen by itself. That is called self-phase modulation. Cross-phase modulation means another frequency is get overlap. They are walk off. The another frequency is getting crosstalk of another spectrum. It is overlapping the spectrum. Is called cross-phase mode. Four-way mixing means the three optical frequencies are combined together. It produces what? The new frequency is called four-way mixing. Scattering effect means for Brillouin scattering, when the light energy is hitting in the optical fiber, it is divided into two parts. One is optical. I suppose there is the acoustic frequency and normal optical photon frequency. But in stimulated Raman effective, it is only giving the low energetic optical frequency, because some of the optical frequencies are absorbed by the molecule itself. That's the reason we are doing nonlinear effects. So this is the complete idea behind the nonlinear effects. So it's no issue. So we will discuss those things. So next one, we move on. The network, optical network. We are moving to optical network. Okay. Next, we are moving on optical network. Okay. Can you see the slide here? Yeah, thank you. So in this optical fiber networks, so network terminologies, what are the network terminologies? Station. Station means the device used to network subscriber. We are the mobile station. Mobile station means we are the users. Stations means users. Network is a collection of interconnected stations. Node. Node means what? The point where one another more communication lines terminate. And trunk. Trunk means it is a transmission line that's opposed to large traffic loads. Topology. Topology means the logic way to connect. The logic way, the nodes are interlinked to each other by the information of transmitting. So it's known as, these are the terminology: station, network, node, trunk, and topologies. So the public network is already, we know this is the part already, you know that what is WAN, wide area network, MAN, metro area network, and PON, the access network, that is the access network, and finally LAN. LAN means local area network. That we know very well. So that's, I'm just moving on to the next slide. The protocol for stack model. What are the, we know the layers. What are the layer? Physical layer, data link layer, network layer, transport, session, and presentation, and application layer. These are the different type of layers, 7 layers of the layers. It's called protocol. What do you mean by protocol? Anyone? What do you mean by protocol? Protocol means what?
Protocol means standard to transmit the signal.
Excellent, excellent. Give a very great applause for Alan. The protocol means it's a standard or a rules of regulations followed by the particular standards. So it has a, so definitely my data will start from physical. Then it will go to data link. The data will not directly go for session layer. So there is a 7 steps. We have to, for example, if you want to go meet our director, means first we go to get the appointment from the secretary, and she give the appointment. Next we will wait for a minute. After that she allow. Then we can move to see our director. So there is a protocol. There is a rules and regulations. There is a standard for next level. What is the next level? What is the next level? That is there is a rules for the each levels is known as the protocol stack model. So this is the 7 layers. Already we know. So we know that we studied this one in a networking system. So I don't want to this one. Only my concentration on optical network one. So I just skip over this. So network layer concept, network architecture, protocol stack. Could you see my present slide is going on? Could you see it? Yeah, thank you. So network architecture, protocol, yeah, protocol and other things are also available. So this is already we know. Optically, this is the exact point what we want to connect. The previous one is general network, but now we are moving to optical network. So the optical layer is a wavelength-based concepts. Here, all are wavelength-based concepts and lies just above the physical layer. So it always under what? It is under before the physical layer. So optical will be between what? Data link layer and physical layer. Physical layer means what is physical layer? Anyone can say what is physical layer? Physical layer means what? Yeah, what is physical layer?
It's used for their things just for the physical transmission. That means the first there.
Actually, for example, wired, we are connecting the wire, right? The wires are carrying the information.
The physical one.
Yeah, cable, yeah. The medium what we are doing, wired cable. But here, what is the things what we are using? Instead of twisted pair or coaxial cable, we are using optical cable. We are using, so the optical network is under which layer? Physical layer only. Optical layer, which is belongs to the physical layer only. That's why it is also very near to the physical layer. That is the optical layer, optical network. So the optical layer provides physical connection between 2 nodes. The optical layer provides light path service over the link. The optical layer process wavelength multiplexing, adding doping wavelength, and support optical switching. So this is the optical layer networks. You can see the physical layer. So the physical layer is connected by SONET and SDH modes. We are missed here. The synchronous optical network. The synchronous optical network is called SONET. Synchronous, S for synchronous, O for optical. NET means network. So what is a SONET? SONET means what? Synchronous optical network. S for synchronous, O for optical, net for network. NET, net for network. So is the TDM. TDM means time division multiplexing optical network standard for North America. So it's called synchronous digital hierarchy. So SDH means, what is SDH? SDH means synchronous digital hierarchy. There are two type of network. You can see the here you can see in the down of it started with what? SONET, SONET and SDH. SONET means what? What is SONET? Synchronous optical network. SDH means what? Synchronous digital hierarchy. Synchronous digital hierarchy. So there are two type of networks out there. Is the rest of the world. North America using what? North America using SONET, and the SDH using the rest of the world. All we are using SDH only, no SONET. The SONET and SDH are the optical network types. So that is different types of optical network, SONET and SDH. In other countries like other than North America, all the countries are using SDH technology. The SONET is the basic physical layer standard. Other data types such as ATM, IP, transmitted over. So like IP Internet Protocol also is there, and ATM protocol also can be used to transmit the data in our optical fiber cable. The OC consists of 810 bytes over 125 microseconds. So this is the number of bytes per seconds, bytes per microseconds. So it consists of the speed only. Remaining all are you got it? Remaining you people can see the slide. I think Reddit is raising the point. He couldn't see the PPT. What about others?
Okay, now I'm seeing, doctor. Thank you.
Okay, Reddit. Okay. So the synchronous
Okay.
optical network. So there is a linear multiplexed and demultiplexing odd drop multiplexers. This is about the synchronous optical networks. So this is the SONET, and what is SONET and SDH? Both are same standard of physical layer of optical network, but the SONET is followed by North America. SDH is followed by the other people, other things. You can see here there is the basic formats. You can see the 3 cross N, the 3 cross N for selection and overhead, and N columns are path overhead and SPE. So this is the complete structure of the structuring model of SDH. So in fiber, what is the layer 2? How many columns? 90 cross N columns are there. How many rows? 9 rows are there. In the 9 rows, the 90 cross N columns, 3 cross N columns are dedicated for section and line overhead. N columns are dedicated for the remaining 261 cross N columns is a combination of SPE as well as path overhead. So this is the structure of SDH and SONET. The common values of OC and stems. This is the standard. What is the line rate, megabits per seconds? What is the common rate, and other things and all is given by the table. It is the standard and electrical level and SDH level, and this is all the SONET level. This is the SDH levels. What is the data rate for each the network system was given clearly. This is the SONET odd drop multiplexer. You can see OC48, ADM, and OC48. OC48 is one of the standard. You can see here OC48 is a SONET network. What is the electrical level? STS48. These are all the industrial name for optical cable. So here we are connecting here OCH and ADM. OCH and ADM is odd drop. ADM means odd drop multiplexer. OC means optical cable. What is that? OC means optical cable. ADM means add and drop multiplexer. You can see here. What is ADM? ADM is what is here? Odd drop. You can see odd drop multiplexer. These are all odd drop. So the linear multiplexing and demultiplexing is possible with ADM, odd drop multiplexing. It can be do multiplexing as well as demultiplexing together. Like a transmitter and receiver can call it as what? Transmitter and receiver can call it as transceiver. Like that here, multiplexer and demultiplexer together called odd drop multiplexing, which is called ADM. So A and ADM steps. This is the SONET odd drop multiplexers. This is general architecture of this one. So this one you can make it as your homework. This slide as a homework, you can draw this one with the AVM multiplexer. And Sonet SDH ring. Here you can see this the Sonet can be configured as a ring or mesh architecture. Topologies. What are the topologies is there? The topologies are ring topology and mesh topology. Yes, Salam, do you have any doubts?
Yeah, the homework. Which page?
Yeah, the page, this is the slide number 10. Slide number 10 of the network. Optical network slide number 10, okay? This one.
Okay.
Right. Good. So SDH, it's combined with the topology, ring topology and mesh topology. And it's another thing is self-healing rings. You can see is wonderful point. Self-healing rings means because the traffic flow along the certain path can be switched automatically to alternate standby. You got my point? See, there is a ring is available. Assume that this primary path is traffic. Completely data is congested in this path means automatically what happened? The transmitter is diverted. The transmitter is diverted to the trafficless path. So it's called self-healing rings. Okay. It is 2 fiber optic basics. Is node 1, node 2, node 3, node 4. What is the topology? What is the topology? Is one? Can anyone say what is the topology here? It is a what is the topology of this network? Yeah, even it is
I
right
think
or
it's mesh topology.
yeah, as a mesh topology also we can say the ring top because it is completely a loop. So we can say it is a completely ring topology because it's wherever it started and it's ending with the same point. So it's a ring topology. It's a ring topology. We can say that it is self-healing. So there is a path. So the node 1 to 3 and 1 to 4 also is possible. This is the total capacity of optical cable with the OC3 and OC2. UPSR basics. This is the fiber optic UPSR protection. UPSR means unidirectional path switching ring. What is UPSR? Unidirectional path switch ring, UPS. BLSR means bidirectional line switch ring. So you can see in this case, you can see in this case, it can go what? Only unidirectional. You got it? Node 1 to node 2, node 2 to node 3, node 3 to node 4, node 4 to node 1. It's only this direction. Unidirectional one. So this is called unidirectional port switch ring topology. Okay. This is same UPSR, but what is 2 fiber connections? This one is what? This is the 2 fiber protections. Here, this is the primary path. What is the primary path? The solid line represents what? Primary path. The dotted line represents the secondary path or protection path. The solid line represents the protection path, and the solid line represents the primary path. This is for transmitter. Another path is available here. This is the receiver compares the signal received, primary protection path, and picks best one. So it depends upon the traffic, the path will be switched over. You can see here the transmitter has the solid path or dotted line path. There is a 2 paths there. So we can it depends upon the data availability, data congestion, and data traffic. Automatically it switches to whether it is a primary path or protection path. So that makes that the optical fiber has reliable data packets always. So compared to the previous transmission medium, the optical networks are having high mediums. BLSR means bidirectional. You can see there is a bidirectional. There is in node 1, what happened? Node 1 is incoming, and here incoming, and also both are incoming also there. So there is a bidirectional is possible by this way. So that is called BLSR. So in this case, the primary ring device fails in either 3 or 4. Suppose the 3 and 4s are fails means what happened? The affected nodes detect loss of the signal, switch both from the primary fibers connecting to the nodes secondary. So if it is not connected, which automatically it is take over to the protection fiber cable can start to transmitting the data packets. So that is if the entire node fails or both primary and protection in a given span or serve, so but the adjacent nodes are giving primary path. So automatically the adjacent nodes are become a primary path. So it's avoid the failure of the connectivity or any other cable failures. So this VLSR methodology is recovering the failure model of the system. So this is four fiber. You can see all are 2-2. You can see 2-2. It has 1, 2, 1, 2. How many cables are there in each node? There is 4 cables are there. So it is a 4 fiber BLSR basic. So it's what is the beautiful idea behind this 4 fiber BLSR basic is that, yeah, Mr. Reddy, yes, Mr. Reddy, yeah, you can. Do you have any queries? Yeah.
Sorry, doctor. The visual explanation are will go off intermittently.
That's I think it's the problem with the connectivity. Maybe if you have a good internet connections, it cannot be. If your strong connection is required. What about others? So Alan and where is Sirna is available? Akime, yeah, they have.
Okay, I'll try, doctor.
Okay. So it's better if you being with the strong Wi-Fi, and it will be good actually. I think you are not under the optical fiber network. You are in another. You are stilted out.
Okay.
Actually,
I will search for. Thank you, doctor. Okay.
Yeah. Okay. Anyhow, the video is recording now. I'll give the link to you. So whenever you have a time, you can go through the video topic. You can get a point. What are the points?
The guys outside of the network, doc.
Yeah. Due to the network, I think he's not belongs to the optical network. That's why he got data packet is lost. So better in 4 fiber.
Please prepare yourself before.
That's good. That's good. Yeah. So this 4 fiber BLSR basics is giving 4 fibers inside for each node. It's connecting as a ring topology and bidirectional also. So what happened due to the bidirectional and 4 fiber and it's a ring topology. So if there is any failures in any node, automatically the remaining parts are acting as a active node. So it will give you a better connectivity to all the nodes. So BLSR, the fault recognitions. This also you can make it as a homework. The page slide 16. The page slide 16. If any fault has happened, you can see the fault has happened. What happened? It will switch over to the another network. Could you see that? You can see my cursor. Yeah, node 4 and node 3 was under the fault. It is breaking this. Here the break is there. Here the break is there. Automatically, what happened? It is taking another path to connect this node 3 and this is the beautiful point of BLSR fault reconfigurations. Automatically, it is reconfigured by this one. So there is no interruption between the optical fiber. So this is also the second one. How again is moving on. So the complete. So you have to do these 2 slides, like slide number 16 and slide number 17, and you have to explain also. You need to explain by seeing the slide how the fault has happened, how the fault is recovered by this BLSR fiber cable fault recognitions. That also now you can see if you are doing with the fault recovery of optical fiber cable is one of the very good research topic. You are very good enough, and you are very good enough in your research means if you are finding the fault, because there is the huge problem of optical fiber cable is breaking the cable easily. So if it is breaking, also it should not affect the remaining connected nodes. Should not affect the remaining connected nodes. That's why making the system is clear. There are a lot of researches going on. So if you are interested, you can see in the IEEE website what are the fault recovery systems are available for optical fiber cable. This is a mode recognition. It's a general SONET network. This also please make it as your homework. That is page number 18. SONET network, general SONET network.
Sorry, doctor. Can you say it on the screen, the homework one, to take the screenshot?
No, what you want? You need what?
To take a screenshot, the page,
Okay, okay, okay.
homework page.
Okay. No, I will share. I will share this slide to you, to the group now. After finishing,
Okay, okay,
I
okay,
will share
doctor.
this one. No
Okay.
issue. You will get that one. You will get that one. I will share the all slides to you. You will get the points. No issue. Okay. Right. So this is a general network. You can see the local area LAN, the city. It is called long haul and BLSR. This is the complete network of SONET, general SONET network. The ring topologies are mainly based on the site city-wide and large national backbone. So now our internet is based completely worked on what? Optical network only. If the optical cable is breaking, so our total internet will becomes a problem. That is a huge. So the backbone network is optical only for our internet. So passive optical network. So passive optical network is here we are using only the connectors and topologies and all kind of network end to end. It's called passive optical network. You can say basic PON. PON means passive optical network topology, bus topology, ring topology, and star topology. That is you know very well in the previous classes. So just I'm skipping on it. So the star and bus network that we know very well, and network elements of PN. It's very important. The network element of PON. PON means passive optic network. PON. So what is a coupler splitter? Optic coupler and optic splitter, star coupler, add drop bus coupler, all optical switches. These all the network element of passive optical network. Next is the star, the power budget and other things. Star network is very good because if any one node is failure, the remaining nodes are working without any trouble. So it's a star network. It is a linear bus network that we know very well, and it's loading things also given as a formula. It's the odd drop bus coupler. This is the point we have to remember. Slide number 25 is important. Slide number 25. This is called odd drop bus coupler losses. So this is the point what we need to this is the optical. Previous things you studied already. So there are different losses: connector loss, tap loss, throughput loss, intrinsic loss, all losses there. This formula also keep in your mind. Sometimes this may come for your problems also. This is odd drop bus coupler losses. Okay. This is linear bus versus star network. It has a number of stations and power is increased. The star network has low power loss. You can see the star network has low power loss, but the linear bus has, if the number of stations increase, automatically the bus loss also increases. That's a understanding from this graph. This is the passive optical network, PON. Already we discussed. So this is CWDM, the continuous wave division multiplexing technique, bidirectional optical network. This is the passive optical network of CWDM based network. Yeah, this is the very important one. Previous case, this is passive optical network. Here, active passive optical network module. It is combined active also there, passive also. Is OLT, optical line termination, optical network termination, and optical network unit, ONU. So OLT, ONT, and ONU. OLT means optical line termination, optical network termination, optical network unit. So these are all the different modules. You can see here. So the OLT here, OLT means what? Optical line termination. And next one is this ONT. ONTs are optical network terminations. And all the things are connected to us. The ONE means what? ONT, but is located near to the customer. ONU means optical network unit, which is located to the subscriber or the users. So the OLT is a first one, and OLT is the second one. Here the splitters are there. Here are the splitters, the multiplexers. The protection methods, how the protection methods are in the PON. Yeah, this is the protection methods. Is there the protection methods are the traffic sources? What are the traffic sources and how it is to be protected? If anything is congested, automatically it is. If fault is redundant, is keep on changing its protections, the layers. So this is the demonstration of PON protection methods. WDM networks. What is WDM? Anyone can say what is WDM?
Wavelength division multiplex.
Excellent, excellent. Great applause to Alan. Wavelength division multiplexing. So single fiber transmit multiple wavelengths. If you want to, in a single fiber, we have to transmit multiple waves. Obviously, we need WDM networks. This can add another dimension to the optical layer. So wavelength converts cross connectors, optical networks, and protocols are independent. So this is the architecture, the broadcast select and wavelength routing. So this is the architecture of the single hop broadcast and select WDM based architecture. It's a star coupler. It is a bus coupler. The star coupler and bulk is ready for multicasting and broadcasting. So multicasting can by bus technology, broadcasting can do by star topologies. So this is the WDM means each cable can produce different wavelength and different data can pass by one single wavelength, single optical fiber cable. That's a single hop. A single hop multicast WDM network. So this also, I think, please all of you note it down. Slide 33, you note it down. Just you concentrate and you get some more point about the single hop multicast WDM network. So it's kind of what is the topology? The topology is what here? Anyone can say what is the topology here? Here, what kind of topology is connected to this WDM network?
Star.
Star topology. Yeah, very good. Star topology. Excellent. It is a star topology. So here it is a star topology. WDM multi-hop architecture. This is good. This is a single hop. Here it can hop any places. It can my data can hop means jumping over there. It can hop any things. It's a WDM multi-hop architectures. And how the data package, the first header and data below. In header, source identifier, destination, and other control. This is the common data packets, as you know, in networking in your BSc. So it's a shuffle net, it's a shuffling network. So wavelength routing, it is routed by the wavelength, not by the data packets or any other things. The wavelength, the routing by its wavelength. The optical drop multiplexing. Already we discussed what is ODM. Optical drop multiplexing is used for multiplexing and demultiplexing. Together is called OAM. We can say OAM. So OADM. Some places OADM also is possible. So the OADM is used for doing multiplexing and demultiplexing of our wavelengths. So reconfigurable OADM also there. ROADM means reconfigurable. We can configure it. We can change the network nodes and other things. Once if you fix it, but there is a scope of changing. It's called reconfigurability. That can be possible by using this network. So this is also one kind of architectures. The special features is wavelength dependence. RODM is degree is a number of bidirectional multi-wavelength interface and express channels. So this is the features of ROADM. And wavelength blocker configuration. This also you keep as a note. Slide number 40. This is a reconfigurable architecture. You can see optical amplifier is there. Optical coupler is this is the symbol for optical coupler. This is the symbol for dropped channels, and it is added channels. And this optical fiber cable is given to the optical coupler. And this is the wavelength blocker. So wavelength blocker, this is used to do completely depends. You can increase the number of fiber, decrease the fiber. That can be possible by using this configuration. So this is the wavelength blocker. By using the wavelength blocker, our reconfigurability is very stable and is giving good idea. Optical burst switching is one of the another methodology. So it is used for very high traffic. Whenever the traffic is very high, especially for high metropolitan cities or very metropolitan areas or capital of the country or whatever it may be, the high traffic places, obviously the optical burst switching is used for the architecture. This is called OBS network. OBS, optical burst switching network. This is the optical cross connect. Already we discussed those things in our I think second class or something. So here this is the optical 12x12 optical cross connect. So this is the how it's working. So optical domain, it can route and other things and all. So this is optical cross connect. This is a 4x4 optical. This previous one is general optical connect, but it's a 4x4 optical connect. The IP versus IP over WDM, DW. So the IP means what is IP? Internet protocol. IP network has redundant management function in each layer. So the layering method was not efficient for transporting IP traffic. So the IP given to SONET, and the SONET is given to what? Sorry. The IP is given to SONET or SDH network, or the network is that will given to DWDM. DWDM means WDM means wavelength division multiplexing. DWDM means okay. Okay. So it's a kind of wave division multiplexing technique. So this is the general method. A general method how the IP is going to given to SDH and finally is ended with the DWDM. So the starting point is IP and is ending with the DWDM. It's a kind of the whole architecture is belongs to the SONET only, right? So this is optical Ethernet. The optical Ethernet is from the center office. We are directly connect to the LAN. This is the LAN area. So the Ethernet kind of cables are connecting to the what we are using our college is like a direct connection of our optical Ethernet cable. Is optical Ethernet. The standard is 802.3 AH. That is a IEEE standard for optical Ethernet cable. So the first mile, the network infrastructure connect the business or residential subscriber, the CO of the telecom carrier. So the three physical transports can be possible. One is individual point-to-point, single point-to-point, multiple users, and a single bidirectional PON. That means passive optical network is possible. This is the complete idea behind optical network. Okay. So just I want to make you the fast recovery. First, we do the terminologies and the types of network: WAN, MAN, PON, and LAN, and the protocols. And finally, what is the network layers things? And optical layer means it's a physical layer. Obviously, it is a physical layer, but it's connected to the is mainly is dealing with the IP address, IP link, and IP data only. So physical layer. Synchronous optical networks are SONET and SDH. So SONET is using North America, SDH remaining people are there using. And this is the general data structure and this is the general architecture of our allocation of our columns, and what is the my rows and columns are dedicated for each session. It's a common standards and it's a data rate. It is a SONET R-drop multiplexer, how it is connected. And SONET SDH is a ring topology. It is a general ring topology. And we can say it is a unidirectional UPS or unidirectional path switching ring. That's called bidirectional two fiber. It is a bidirectional. This is a bidirectional line switched ring. This is not path. It is a line switched ring. Bidirectional line switched ring recovered from the different mode failures. It is 4 fiber, and 4 fiber has a different capability of removing the fault under the cable failures. And this is a general SONET network. This is a PON, passive optical network. Passive optical network, different topologies there, star, tree, and bus. Finally, the network elements is star coupler, odd drop bus coupler, switches, and coupler and splitter, star network, linear bus network, odd drop bus coupler. This is it can handle with the different type of losses. So there is a connector and tap and throughput losses, and linear bus versus star network. It shows that star network has less power loss compared to the linear bus. PON networks, active PON modules. It contains OLT, ONT, and ONU, and PON protection methods, WDM, and how the WDM architectures are there. This is a single hop architecture. This is a single hop multi WDM architecture. This is a WDM multi hop architecture. This is a general data packets of asynchronous data packets, shuffle network, and is a routing done by wavelength only, not for the other things. So order of multiplexing, and the reconfiguratory done by here the blocker network. The blocker channel, the wavelength blocker is giving that reconfigurability. We can add or drop the channel, the number of channels inside the network. That is a wonderful point about the reconfigurable optical network. So optical burst switching method is used for metropolitan cities because of huge traffic. This is a 12x12 optical cross, 4x4 optical cross, and IP over WDM, and finally the optical Ethernet. So these are all the different type of things is available. I think I'm just closing my session. So today we discussed the two important topics, which is called stop sharing. So today we are discussing the two important topic called nonlinear effects and networking. The nonlinear effect means, what anyone can summarize? What can you say nonlinear effects? Anyone? Now, can I see your face? If it is possible, you don't want to open your audio. Can I see your faces if possible? I want to see. Is it possible to see you? Because I want to know. Oh, yeah. After a long time. Akeme, I'm so happy. Agmas and Alan. So nice to see you all. So it's very happy. So I'll take a print screen.
You too, doctor.
Yeah, it's really happy to see you all. So I want to summarize, just make a remembrance. Give me, I will take 2 minutes of time. Any one point strike in your mind, you just share it. What does a nonlinear effects means? Two nonlinear effects. One is what is it? One is scattering nonlinear effect. Another one is four-wave FWM. Four-wave mixing. So two effects. Scattering effect divided by 2. One is Brillouin and Raman effects. And FWDM is 4. Four-wave mixing is single phase modulation and cross phase modulation and four-wave mixing. This is the complete idea behind nonlinear effects. And the network is that SONET and SDH. It has different topologies and different type of networking. Four fiber, and single fibers, unidirectional, multidirectional, and multi-hop, single hop, and broadcasting, and we can say the fast switching in network for metropolitan cities also. There are different types is available. You can see. So this is the complete idea of optical. There are a lot of scopes in optical network. To do your research. You can see for finding the fault. Actually, if you have the fault in the network, just you can see IEEE. Just you type it. What is the fault? How to find the fault recognizing system is one of the huge. If you are having such a skill, most of the Safari and Yahoo Telecom facing this problem right now, because the cable is easily broken. If it is broken, means that will lead the remaining people get also the nodes also is not working properly. For that, how to tolerate the fault tolerant system. Please note it down, all of you. Fault tolerant system. Fault F-A-U-L-T, fault tolerant, T-O-L-E-R-A-N-T, tolerant system, fault tolerant system on optical. This is the beautiful topic. If you work on this topic, if you have very good idea, you are the most expected person in the optical communications. Now you see 6G technology going to benefit by optical only. 6G technology is going to hand with the optical only. So if you work on optical, obviously you will get a lot of opportunities. Maybe you will get more placement in our companies and other things. So my personal advice is that you have to go through, and I give a case study to everyone as your group. You are the group, right? So this group you will take Salam and Akime, Len, Agmas and Reddy. These 5 persons you are in the group. So you are going to, this is the group assignment I'm going to give you. So the group assignment name is, what is the group assignment is it? What are the different fault tolerant systems are developed in optical system? What are all the different fault tolerant systems are developed in optical fiber communication system? So what is your work is, Salam will download 10 papers. Akime 10 papers, not for same papers. For example, Salam, you can start your title area year is 2000 now 2026, right? We can move on 10 years before 2016 you do, right? Check it in the 2016. What is the, how many papers, how many things? And Akime 2017, and Allen 2018, Aguma 2019, Redhead 2020. So 2020, what are all the fault tolerant systems are available? This was developed. Those 10 paper only you have to download. After downloading, you will come, you have to do extract the point and you make it a single thing. Okay. So I need only the extraction of each thing. When you are doing such a things, you will get more knowledge on it. Got it? So do it all. My first. Suppose Salam and Akime, you didn't get more paper on 10 papers you didn't get in this year, means you can go for the next year also. No issue. No issue. So what I'm saying, suppose in your year 10 paper is not getting, means even you can go for up and down, but make 10 papers with you. You collect the 10 papers from research papers from IEEE and you do work on it. Okay. Okay. Nice to work with you. Nice to be with you this session. Anyhow, the session started at 1:30. Now the time is almost 1.5 hours. We spend over this online platform. I'm happy to be with you, and I really miss the other guys. Why those people are not coming? But anyhow, I just make this recorded video and I upload it someplace, and you can review after my YouTube. I will upload it. Then you can go and check it. What is the things going on the before classes. Okay. So nice to see you, and have a great day to you. So we'll see you the next thing.
Thank you,
Doctor.
Doctor.
Thank you so much. If possible, give me one more class, because if you one more class, I'll finish optical. I'll finish optical. Even if you just discuss with you guys, I need one more online class. If you give that one, we'll finish the total optical system. I will share all the slides and other materials to you, to our new group. Then you can utilize it. Okay. Have a great day. We'll see you on next class. Thank you. Thank you so much.
Okay, Doctor. Thank you. Thank you. Have a good time.
Fine. Thank you. You can leave.